Okay, now we're going to move on to matrix multiplication here, which is a little bit more complicated. Once you get used to the pattern, you get faster at it, you get better at it, but it takes practice. So this says the product of two matrices A and B is defined provided the number of columns in A is equal to the number of rows in B. This has to be true. This must be true. We always check for that first. Okay, the best way to check for that is kind of what this is showing right here. If you write out the dimensions of matrix A and the dimensions of matrix B, put them side by side like that, then you can compare these two numbers right here. Those are the two numbers that we just talked about. The number of columns in A would be, since we say rows by columns, would be that n that I've highlighted in yellow right there. The number of rows in B will be, when we name the rows, we always name rows first. So B has to have the same number of rows. I just highlighted that in green there. So when they're both the same number, in this case, they just call it n. When these are equal, then we can do the multiplication. So I'll just put a check mark right there. You can do it if they're equal. If they're equal and you can do it, then here's the next step. You know what the dimensions of your new matrix are by comparing these two numbers or putting those two numbers together. These two outside numbers will be the dimensions of your new matrix. So the rows from A and the columns from P. And that's what that's trying to show right there. Okay. So let's just come down here and look at an example to see if we can actually do it. So I'm going to skip down to example 1 here. This matrix here is a 1, 2, 3 by 1, 2. This is a 3 by 2 matrix. So I'm just going to say we have A being a 3 by 2. Write this up a little bit higher here. Okay. B, if we want to call it that, is a 2 by 2. So the first thing we want to do is check if we can do it. Compare those two numbers. Okay, I just call them the inside numbers. The columns from A, the rows from B. They're the same. So if these are the same, remember you can do the matrix multiplication. So we're happy because we're excited to do the matrix multiplication. Now, here's what our new matrix is going to be. Here's what the new dimensions are going to be. 3 by 2. So our resulting matrix, A times B, is going to be a 3 by 2 matrix because of those two outside numbers right there. Now, let's move back up here. Now that you've kind of seen how we check for that, let's move back up here. And this is basically kind of saying what we just talked about right there. But here's the key thing I need you guys to fill in here is that we're going to multiply rows times columns. And then I wrote, this shouldn't be that hard to remember, or excuse me, that should be easy to remember because that's the same way that we name the dimensions or the order of the matrix is rows by columns. That is the same way you multiply. So when we end up multiplying these together, we're going to multiply rows by columns. Okay, and we'll talk about how that works in a second, but that's kind of the main idea. So let's look at the next matrix set of matrices here. We have A being, I'm just going to do it with my dimensions here. We have a 2 by 2 and we have a 3 by 2. In fact, I'd like you to notice these are the same two matrices. Okay, so maybe it would be a good idea here to call this B and this A because they're the same matrices that we had before. B is a 2 by 2 still. A is a 3 by 2. So look at now, those two numbers are not the same. Can't do it. So that tells us two things. First of all, this is our first example where we have two matrices that we can't multiply together. But another important thing to notice is we're using the same two matrices and we flipped them around and we can't even do it. That tells us something pretty important right here, that matrix multiplication is not commutative. Order does matter. Even if we could do both multiplications, AB does not necessarily does not necessarily equal BA. They might by, some crazy thing that we're going to talk about later on, one of them being the identity matrix. But for right now, just know that they're not commutative. You can't flip things around here. So it's important to know what order you're going in. So I wrote, get in the habit of writing the order of each matrix and multiplying. This is going to help you determine the size of the n matrix. So we're always going to do that. So let's talk about how we actually do the multiplication here. This is basically it right there. Okay. When we multiply these together, we're going to be taking the row times of one matrix, so the first matrix, times the column of the second matrix. And when I say we're going to take one times the other, we multiply corresponding entries. and then we add those products together. So in this case, what we do first is we take A times E. And then we move to the right in our row and down the column and take B times G. So you see those two products right there, and what we do is we add those products. All right, so the other thing I'd like to point out here is this is row 1 and row 2 of that first matrix. This is column 1 and column 2 of that second matrix. When we take row 1 times column 2, that gave us the row 1 column 2 spot there. When we take row 1 times column 3, row 1 times column 2, so when we take that guy times that guy, that's going to give us the row 1 column 2 spot in that matrix. Okay, and what I mean by that is when I multiply that row and that column, I'm going to get the row 1 column 2 spot in this matrix, which is here's the first row, there's the first column, there's the second column. So there's the first row, second column. So you always know kind of where you're working in the matrix. All right, let's take a look at this first example here. We have A, and if at any point in time I'm going too fast, or if you didn't catch something, rewind it. And if you still don't get it, shoot me an email or come in and ask. We have a 2x2 and a 2x2. For sure we can do this. Okay, not only can we do this, but we know we're going to get a 2x2 in the end. That's going to be our resulting matrix. Okay, after we do the multiplication, we know that AB is also going to be a 2x2. All right, so even though I know it's going to be 2x2, I'm going to make it a little bit bigger because we have a little bit of work to show here. So I know it's going to be a 2x2, so for these early examples, I do something like this. I put these big spots, big kind of placeholders in my product matrix. Okay, I know I'm going to be taking the first row times the first column to get this first row, first column spot there. When I do that, I want to take the 6 times the negative 1, and I want to take the 1 times the negative 5, and we want to add those together. It's always addition there. Okay, it's always addition right there. All right, so I'm going to worry about what that gives us in a second. Actually, for this one, no, I'm going to go ahead and in this one spot, I'm going to come over here and say that's going to be negative 6 plus negative 5. And I'm going to go one more and just give that last value. Negative 6 and negative 5 is negative 11. Just so you see, in the end, we just get a single number there. Okay. Now let's find out what our other products are. All right, I'm going to stay at that first row. I always like to take care of my rows first. So I'm going to stay in that first row here. So I'm going to stay in my first row, my product matrix. But now this time, I'm going to move over to the second row, the second column. Second column in that second matrix. So that's going to give me this spot right here. Okay, so we're going to have 6 times 7 and 1 times 3. Right, we're not always going to be showing each of these steps for this. Okay, at some point in time, you might be able to go right to there. All right, I'd be careful doing that on a quiz or something, but as you get good at your mental math, you can start kind of skipping 1 or 2 of these matrices here. So we're going to have 42 plus 3, which is 45. Actually, I can make this one a little bit more condensed. 45. All right, now we're done at this row. I've ran out of columns over here. So now we're ready to move down to the second row, which means I should be in my second row, my resultant matrix, which I am. Everything should kind of work together. So I'm in my first row. Okay, now let's say you forget where you're at. Look at this matrix. You're trying to get the second row. Okay, here's row 1, here's row 2. You're trying to get the second row, first column spot. That means you need to take that row times that column. So you know exactly which ones you should be multiplying together in the original matrices. Okay, so let's go and do it here. 0 times negative 1, 2 times negative 5. So we're going to have 0 plus negative 10. A little too big there, which is negative 10. All right, last one. Okay, again, let's say you lose your place. You forget, where am I supposed to be right here? Which things do I need to multiply together together to get there. Remember, you're in the second row, now the second column spot. So you need second row, second column. So we have 0 and 7, that's 0. 2 and 3, that's 6. So we get 6. So if there's a matrix you're going to skip, it's actually probably that first one right there. And probably go to that one. I'd write something down so that if you do make a mistake, you can go back and find out where it happened instead of kind of starting from scratch. All right, next example here. Let's see if we can even do it. We've got a 3 by 2, rows by columns, 1, 2, 3, 1, 2. A 3 by 2 times a 2 by 2. So we can do it. And our resulting matrix is going to be a 3 by 2. We know we're going to get a 3 by 2 in the end. I'm just going to write AB is going to be a 3 by 2, just so I kind of know. So 3 rows, 2 columns. So I'm going to have one more row here than I did before. Okay. Now when I do this one, I'm going to try to go right to that second matrix, okay, in this problem. So I'm taking first row times first column. So we're going to have 15, 5 times 3, plus negative 2 times 6 is negative 12. And if you want to write just minus 12, that's fine. All right, I'm just going to keep moving. Staying in that first row, and I'm in the second column. 0 plus negative 4. Done with that first row. Moving down to the second row. So we have 0 times 3, which is 0. 2 times 6, which is 12. Those are the ones I was just doing. I'm going to do the second row, second column. Again, you lose where you are. Let's say you lose where you are. I need this one. That means I need 1 second row, 1, 2, second row, 1, 2, second column. So I need second row, second column for the spot that I'm at there. So I have 0 times 0, which is 0. 2 times 2, which is 4. Done with that row. Down to the last row. So we're going to take the 1 and 1 times the 3 times 6 to begin with. 1 times 3 is 3. 1 times 6 is 6. And then I'm going to stick with that row and go to that column. We have 0 plus 2. All right. So we have 3, negative 4, 12, 4, 9, and 2. Okay. I was thinking about skipping this one, but kind of like what happens here. So think about what type of dimensions we have here. It's kind of confusing looking. Look, it only has one row, but there's 3 numbers, so that means it has 1, 2, 3 columns. So this is a 1 by 3. This guy is a 3 by 1. So we can do it because of the 3's. Check. And our resulting matrix is going to be a 1 by 1. Okay, be careful with that though, because we're going to have some multiplication here. So I'd like to write some stuff down. But I know this is just going to become one number in the end. So we're going to take the 3 times the 2, and the 1 times the negative 6, and the 1 times the 0. And we add those all together. So we have 6 minus 6, which is 0, plus 0. This is called a null matrix, or an empty matrix with just that element 0 in it. This is just coincidence that became that. But it's kind of interesting that we had a 1 by 3, 3 by 1, but because of those 1s there, we had a 1 by 1 to end with. All right, the next couple problems are order of operation problems. So for example, in this example 5, you'd have to do both of these products first. Okay, and you can do them because they're both 2 by 2s times 2 by 2s, so you can do both of those. This one down here is asking you to add A or B to A first, and then multiply A times that sum. Why don't we take a look at that one as an example here? So we're going to do the B plus A first. Don't worry about like distributing. You could and get the same thing, but then you have more multiplication to do, which I think you've seen that addition is a lot easier. So let's do this first, the B plus A. So B plus A is going to give us 5, -2, 2, and 2. Let's just look at that again. 5 plus 0 is 5. Now, I'm actually looking at this way as a plus b, just because it's left to right the way that I'm looking at it. And matrix addition is commutative, so it's okay to do that. I can flip these around if I want to. It's the multiplication that's not commutative. So we have b plus a being 5, -2, good, 2, and then 2. Perfect. So that's what's inside that parentheses. Now, that's going to be multiplied by a. Now, make sure you put things in the right order this time. So the a is on the left. So you have 5, -3, -2, 4. So obviously we can do it. It's a 2 by 2 times a 2 by 2. All right. So first we're going to take that row times that column to get that spot. So we're going to have 5 times 5, which is 25, -3 times 2, which is -6. Stick that first row and go to the second column to get that spot. 5 times -2 is -10. -3 times -3 times 2 is -6. Okay, just looking at things real quick. 5, -2. I just want to make sure I got my values right here. All right, done at that first row, so I'm going to come down here. You have -2 and 4, 5 and 2. So -2 times 5 is -10. 4 times 2 is 8. Going to move over to that second column. -2 times -2 is 4. 4 times 2 is 8. All right, now we're just going to add our products together there. We'll get a 2 by 2 in the end. So we have 19, -16, -2, and 12 as our final matrix there. All right, let's take a look at this last one here with the matrix equation. Basically, this comes down to writing out how you would do the multiplication, okay, and then solving the resulting equation. So I'm going to look for where my variables are. I have 1 in that bottom column, and then I have the y right there. Let's worry about that x first, and we'll worry about the y second. So I know that if I took that row that I just highlighted and multiplied it by this column, for example, that would be row 2 times column 1. That should give me that spot there. That's in the row 2, column 1 spot. So I know that if I took -2 times 9 and added it to x times 2 and added that to 1 times -1, that should equal -13. So I'm just going to simplify. -18 plus 2x minus 1 equals -13. I have -19 over there. I'm going to add that over and get 6. 2x equals 6 and x equals 3. All right, let's just put that back in and see what we get here. We should get a true equation. I'm going to check that back in. So if we took -2 times 9, 3 times 2, and 1 times -1, I have -18, so -12 minus 1 is -13. That checks out. That was good. All right. So we have our x value. Let's find our y value now. Y is right here. So that's in the first row, first column. This time I don't have a choice. I've got to go here and here. First row, first column. So I have 36, 4 times 9, plus 1 times 2, plus 3 times -1. That should equal y. So I just need to combine those together. So we have 35. So we have our x and our y there. All right, that is a quick rundown of matrix multiplication.